Hello everyone, this is Saurabh Kumar and I would like to welcome you all for this video where I am going to talk about OSI reference model, which is one of the most important topic of networking, and if you are having a career in IT, we all know how important it is. So let's begin. First of all, I would like to tell you what are the point or topic I am going to cover in this particular video. So I will be talking about history of OSI. I will be talking about introduction of OSI reference model. Then I will be also talking about explanation on all 7 layers of OSI reference model. Then I will be comparing OSI model with TCP IP model, which is also known as DoD model. And at the last, I will be trying to explain you in a layman language with some example, and then I will be summarizing it. So this is what we are going to cover in this video. So let's begin. First of all, when we talk about the history, here you see that in early and mid 1917, that period of time, networking was largely either government sponsored, so either the network was being used by any of the government organization, or either it was a vendor developed with proprietary standards, such like IBM was having its own network architecture. The another one was DEC Net, which is known as Digital Equipment Corporation. So that is how it was being used. It was not being used by publicly like the way we are having right now. So in the beginning of 1977, the organization which is known as ISO, which is for standardization, they conducted a program to develop general standard so that this standard will be used and followed by everybody, and the method of networking. So because of that, they have built a kind of committee, or they made a kind of group, and in 1983 two organizations, one is CCITT and another is ISO. Both of them, they together merge their information, their document, whatever method or standard they were making, and they introduced it as a name of Open System Interconnection, that is OSI. So nowadays we are calling it as a OSI reference model, or maybe simply OSI model. So what was the time or year when it was introduced first? So it was published actually in 1984 by both ISO and CCITT. So ISO gave it a standard code which was ISO 7498, and there CCITT, which is right now known as ITUT, they have given it a standard that is X.200. So that's the standard given to this particular OSI reference model, and which talks about how or which method will be used by the computer to communicate with each other. So finally, when I talk about OSI, it is what it is actually a industry effort attempting to get industry participant to agree on a common network standard to provide multi-vendor interoperability, meaning that it was a kind of a complete industry effort to get ready on a one type of method, one type of mechanism will be used on a network, one standard will be used so that all multi-vendor devices can easily communicate with each other. So when I talk about the definition part, simply what is OSI is, so it is a conceptual model which characterizes the standardizes the communication function of a telecommunication or computing system without regards to its underlying internal structure and technology. So in a normal way, I can tell you that it was, as per its name, open system interconnection, meaning that it was trying to give you open system interconnection. Like if you have a device from HP, if you have a device from Cisco, if you have a device from D-Link, if you have a device from any other third vendor, so they all will be able to communicate now because of this OSI standard, because they all are these all organizations, they all are following the same method, same standards when they are manufacturing the device. So for example, if you buy a router from Cisco, they are also following the same 7 layers of OSI reference model, and if you get a computer from Dell, they are also following the same. So the thing is now common, they are using the same standard, and that's why it is now easy to have the communication between the different vendor devices. So that was the main reason of introducing the OSI. Now when you go through the document of X.200, it is described as a 7 layers, and it has given label from 1 to 7, where layer 1 is known as the lowest layer in this model. So let me have the name of it. we have the layer 1, the lowest layer, which is known as physical layer. Then we have layer 2, the name is Datalink Layer. Then we have layer 3, which is network layer. Then we have layer 4, known as transport layer. We have layer 5, known as session layer. We have layer 6, known as presentation, and where 7th and the final layer is application layer. So when you talk about these 7 layers, what you can see here that we have given the number, or we are counting it from down to up. So when you are counting, we are calculating like this. The down one is layer 1, then we have layer 2, then we have layer 3, then we have layer 4, like that. So it doesn't mean that always the data first will go to physical layer itself. It depends on either your computer is a sender or either it is a receiver. So if I talk about two computer, for example, we have one computer here, another one here, and if this is a sender and this is receiver, so at the sender side it is going to follow a process starting from layer 7, then 6, then 5, then 4, then 3, then 2, and then 1, and then at the receiving it will be just followed in a reverse way. So first the data will be processing at layer 1, then it will be going to layer 2, then it is going to layer 3. Let me try to explain the same thing in a graphical way here. So here you see we have two computer. I am assuming that this guy is a sender. So this is a sender and it is a receiver. So when a sender is trying to send something, how it is going to be? So first of all, when sender is sending a data, it will be crossing like this. It will be going to layer 7 first, then layer 6, then layer 5, then layer 4, then 3, 2, and then finally 1. So the process will be followed like this. And then when we talk about going to media, so whatever data will be transformed in, that data will be traveling over the media here. So it will be sent over the transmission media, whatever media you have, either you are using cable or Wi-Fi, or in a cable also either you are using copper cable, either you are using fiber optic cable. So after being received from the media, at the receiving end, it is going to be in a reverse format. So first the data will go to the first layer, then second, then third, then fourth, then fifth, sixth, and finally it goes to 7th layer. So meaning that at the sender side, the data will be followed from layer 7 to layer 1, and then at the receiving side, it will be followed from layer 1 to layer 7. So that's why when we write the name, we start writing from the top, which is application layer, then presentation, then session, like that. And when we count it from down, physical, data link, network, transport, like that. Let's have some more detail on it, how the data is going to be transferred here. So let's take an example that we have two devices maybe sitting on a different network. So to make them connect, obviously we are going to use intermediate node, or maybe we can call it like a router. So if you have a router there and your network is in such format, how the data is going to be traveled by using OSI reference model. So our computer is going to follow all the 7 layers here. So the data will be followed like this. It will be passing through layer 7, then 6, 5, 4, 3, 2, and 1. And then when it reaches to the another device, depending on the device type, like for example in this diagram we have a router. So router works at layer 3, the meaning that the data will be converted back to physical layer, data link layer, network layer, that is 3rd layer. And then at 3rd layer, router will understand which device is a sender, which device is receiver. Accordingly, it will forward this data back to the another device. Another device is again a router, so the data will be passing up to network layer. It will be verified and checked here again, and then it is going to send again to the receiving device. And if receiving device is a computer which follow all 7 layers, so now the data will be reaching there and he will be able to understand. So very simply, every layer are having some specific task to do, and that we have to be knowing that what exactly every layer is doing there. So let me start talking about each layer one by one. First I am starting with application layer. So what application layer does is, whatever data you are trying to set or whatever type of communication you are going to have, very first thing that at the sender side, it is going to be checked at application layer. So here application layer task is that which application access the network service, that will be filtered, that will be checked by the application layer. So generally it is going to represent services that directly support software application for file transfer, database access, electronic mail, etc. In a layman language, if I tell you what application layer does, that it checks what type of communication you are planning to have. For example, you have a computer here and you have another computer here. What you want to do between them? Are you planning to send a maybe file? Do you want to do a file transfer? That means you are using FTP protocol, and that's your application. Are you planning to send maybe an email? So email is going to be used by SMTP protocol, and that's the application you are using. Are you planning to do anything else? Maybe you want to do remote access, so are you using telnet there? So this way it will be checking what application you are planning to use here between these two computers. That will be checked by the application layer. So in short, application layer is checking what type of application, what kind of program you are planning to do between these two computers. After checking these things, now the data will be sent to the next layer, which is presentation layer. So what presentation layer is going to do? It is going to related to the representation of transmitted data. We know there are so many different type of data are, like you have video, you have mp3, you have text file. So all this text file or any other type of data will be translated first into other type of format. Maybe it will be converted into a language which computer understand, maybe in ASCII code or something. So the major task of presentation layer is three, that is doing encryption, data compression and encoding. So these three tasks will be done at the sender side. So for example, if this is a sender computer and this is a receiver, so what task will be done at the sender side? It will be encoded, it will be encrypted, it will be compressed. Those three tasks will be done at the presentation layer of the sender side. And then at the receiver side, just reverse, that means it will be decompressed, decrypt and decoded. That three tasks will be done at the receiving end by the presentation layer. So it also provides a service for secure, efficient data transmission because of having encryption, because of having encoding. So that's the data will become secure as well because of this presentation layer. Now that after doing this task, after doing encryption, compression, now the data will move to the next layer, which is known as session layer. Session layer plays a very important role here because this is the layer which maintain, establish and terminate the session. For example, you have a sender here and you have a receiver here. So between these two devices, when to start the session, meaning that for example you are trying to do, let's say that remote management, or maybe you are trying to send a file transfer. So if there is a file of, let's say that 6 GB, so 6 GB data has to be transferred there, right? So when to establish the connection, and according to the size, how long this connection is going to be there, managing the session, and then when the 6 GB data will be transferred, then it will send a signal to terminate the session too. So these three tasks will be completed by the session layer at the both side of sender and receiver. So this side is sender side, this side is receiver side. Sender also, the session layer will be managing these three tasks. Receiving side also it will be doing these three tasks, that when to start the session, for how long the session will be, and when to terminate the session. So those are the three tasks completed by the session layer. So it regulates which side transmit, plus when, how long it is going to do transmission. So it performs the token management and synchronization there, so that the session will be managed properly between the sender and receiver side. After this task, now we have the transport layer. So now the data will move to transport layer, and at the transport layer, the task of transport layer is to manage the transmission of a packet. So what generally it does is, it is going to do the repackage long message when necessary into a small packet for transmission. For example, as I told you, let's assume that your data is of 6 GB here. So if your data is of 6 GB, 6 GB data is not going to be sent at a time to the destination. So what it will be doing, it will be breaking it into multiple small chunks, and that process is called as a segmentation, and this packet is called as a segment. So it will be first of all break into multiple chunks. That is the one task of transport layer. Then it is also going to when it reach to the receiving side, it is going to be reassemble also to make them again as a one file. So at the sender side it will be breaked, at the receiver side it is going to be reassembled. That's the one task of transport layer. Second task of transport layer is also giving them a number, because there are many number of packets this segments are. So giving everyone a number is also a task of transport layer, and that process is known as we are calling it that you are giving a sequence number. And that sequence number helps a lot when we talk about the receiving it. For example, you have a picture here, and that picture is having, for example, this kind of things inside. So when obviously, as I said, it will be break before it sends. So let's assume that it has been broken into 4 parts. So now each part is having a number 1, 2, 3 and 4, and then it will be sent. So that when receiving end receive it, they will be also adjust these 4 blocks, these 4 segments in a right order to get actual file, actual data which has been sent. Otherwise, if there will be mismatch, if they put number 1 here and number 3 here, number 2 here and number 4 here, what will happen? They will not get actual file what has been sent from the sender side. So that is again second task of transport layer. So it does first of all segmenting, then it is doing sequencing. Next task it also does it transport layer at receiving acknowledge packet delivery, depending on which protocol you are using. So actually at transport layer, two protocols are working there. Those two protocols are TCP and UDP. So as per you see, TCP is a transmission control protocol, UDP is user datagram protocol. So TCP makes a reliable communication, it is a connection full kind of protocol, where we talk about UDP, it is connectionless, it is unreliable. But UDP is faster, TCP is you can say a bit slower, depending on the type of data. So I will be making a separate video on this, what are the major difference between TCP and UDP. But right now let's try to understand that the transport layer will decide either the packet supposed to be moving by the help of TCP protocol or either with the help of UDP. If it is passing through TCP, there will be a three-way handshake, and then it will be doing error control also. It will be checking each packet, whatever is being received, it will be giving an acknowledgement also. That's why it is called as a connection oriented protocol. And then if any packet missed, for example, it has sent packet 1, 2 and then 4, meaning that 3 is missing, so 3 will be resent from the sender side. These all are being managed by the transport layer. That is what the task of transport layer is. Then the next layer we have, that is network layer. So what is the task of network layer is? It manages addressing, it manages routing of data within the subnet. So generally the most common device at network layer is router. So what router does is, if you have a router receive any data, that is known as packet at network layer. So in each packet it has two type of address, source address and destination address. So by checking that source and destination IP address, the router will be deciding that it should go either to this network or maybe to another network which is connected at another interface of router. So network layer task is to add or assign address of source and destination, where from the data is traveling and where it's supposed to reach. So you see here, addresses message and translates logical address, that is the IP address, and names into the physical address. So it is also having a part like which is going to translate IP address into MAC address. Then it determines the route from the source to destination computer. So which route it has to take. For example, there is a router having a route like this way, then it is having a route like this way. So which route it's supposed to follow to reach to destination, that will be taken care by the network layer, and that will be taken care by router which works at network layer. Then routing can be also managed by the network layer, like based on a static table. If you have configured a static routing, or if you have configured dynamic routing, whatever routing protocol has been enabled on the router, on the basis of that route will be decided. So it determines at the start of each session individually determine for each packet reflecting the current network load like that. So the meaning that network layer also add a kind of header in your data. Whatever original data you have, whatever the real content you have, it will be adding a one more header here, extra information, and that header contains source and destination IP address, logical address. And this format of data is known as actually packet. So what we call it, it is known as a packet at network layer. And then this packet will be forwarded to the data link layer. Now data link layer is a second layer. So what it does, it packages raw bits from the physical layer into frame. So for example, when we talk about at the receiving side, it will be taking bits from the physical layer and it will be converting them into another format. But if we talk about a sender side, what it is going to do, it will be adding again a header. So whatever packet you have received, packet means I'm already telling that data plus a header given by the network layer. So this all is called as a packet. So before the packet, even it will add one more header, and that header will keep information of source and destination MAC address. So what data link layer does is it add the physical address MAC address before that, and then it also add a footer that is known as CRC, cyclic redundancy check, 4-bit data at the end of it, which is like a tail, so that every packet when it reaches to the destination device, they only check this tail. If the tail is available in this entire package, that means the data is safe. If this tail is missing, the meaning that they assume that data has been corrupted or maybe it has some problem, it has to be resent again. So data link layer is completely responsible to add the header and footer. Header is source and destination MAC address, footer is CRC bit for doing the redundancy check. Then at the receiver end, obviously it is going to check the MAC address, and on the basis of that it decide where to go. It waits for an acknowledgement from the receiving computer also, and then it does retransmit frame for which acknowledgement is not received. Maybe if any data has missed or acknowledgement has not received, maybe packet number 3 has been sent but no acknowledgement came, that means it has to be resent. So those are the tasks of data link layer. Then the final layer we have is physical layer. So what physical layer does is it transmits the data into format of bits from one computer to another. So whatever data is moving, actually it will be transmitted into the format of bit. It regulates the transmission of a strip of bit over the physical medium, whatever physical media you are using, either cable or wireless. Then it defines how the cable is attached, which type of topology you are using, what type of network adapter you have, what kind of cable you are going to use. Such kind of things will be managed and controlled by physical layer. So the device which works at physical layer is simply we can call it like a NIC card or your hub. So these devices works at physical layer. So the definition of 0 and 1, example how many volts represent 1 and which will be representing 0, 0 is always ground, that things will be determined by the physical layer. Whether the channel is simplex, means only sending, or is it going to be duplex, sending and receiving both, so that will be depending on the physical layer. It will be determined by the physical layer. How many number of pins are there in a connector and what the function of each pin is. For example, if you are using RJ45 connector, so there will be 8 pins there and each pin is having what role, that will be determined by the physical layer. So that's how there are 7 layers are, and you have seen that each role is having a separate kind of task there. Now when we compare it with the DoD model or TCP IP model, so as I explained, in OSI we have 7 layers, but in DoD there are only going to be 4 layers. So actually what they did is they merged this down 2 layer, then network layer will be as a single, transport layer will be as a single, and then they have also merged the upper 3 layer as a single layer. So when we go through the DoD model, it is going to be having names like this: access layer, which has the combination of data link plus physical, means it will be doing the task of data plus physical. Then we have internet layer, which does the exactly same task what network layer does in OSI reference model. Then we have transport layer, which does exactly the same as transport layer does in OSI reference model. And then we have application layer, which has the combination of all 3 upper layer: application, presentation and session layer. So this is what the difference between OSI and TCP/IP model is. Here we have 7 layers. When we talk about TCP/IP model, here we have only 4 layers. So that's why this OSI reference model is called as a reference model, meaning that it just gives you a reference, but DoD model is the one which we generally implement in real life. So DoD model is the one which is being mostly used by the all different vendors or manufacturer or devices. But for reference, to have a more brief of each layer task, we should be knowing the OSI reference model, because it has a proper categorization of each task which is being done at each layer of the OSI reference model. So before I continue again, I would like to give you a layman language example here. So what is doing, if I compare with the post office, like if we use post office, how do we send a letter to somebody? So the task of application is as simple like somebody is writing a 20-page letter and they want to maybe send it to the foreign country. So for example, I want to send a few letters, let's assume 20-30 letters to any foreign country. So in our post office, what we do, we write the letter, or we decide what kind of data will be there. That is the same like application layer does in our computer. It checks which application is going to be used. Then once the writing is done of your letter, what we do, we put or translate the letter so that receiver can read it. For example, if I am sending my letter to England, or if I am sending my letter to any other country, China, or maybe I am sending this letter to any other country where nobody knows English, then I have to translate my letter in that language so that they can easily read it. Same presentation layer does in our computer. What it does, it represents, it encrypt, it code, it does compression on a data to make in a way that it can be easily transferred and it can be easily understood by the computer. Then the session layer task, as similar like in our life, what we do, ensure that intended recipient can receive letter, something like confirmation which we get. Then at the transport layer, what does it do? So in our post office media, what we do is we separate the number of pages, like registered mail will be separate, track delivery will be separate, request another package if anyone lost or damaged. That same kind of task will be done at transport layer. It does error checking, it does segmentation, it does sequencing. These all tasks will be done by the transport layer. Then at the network layer, as similar like when we are writing a letter, we add a zip code when we are sending, and when we talk about receiving it, they filter the letters on the basis of zip code. So that if zip code is, for example, 824235, which zip code, which particular local area it is, on the basis of that they filter the packet. Similar like that here also, on the basis of IP address, it filters the packet. Then at the data link layer, as simple like we are determining which vehicle is going in that way, maybe to that street or something. Similar to that, data link layer is checking the MAC address, and on the basis of that it is going to decide where it's supposed to go, which device is the receiver actually. And then the physical layer is as simple like what media we are going to use to send our data, to send our letter. Either we are going to use truck, plane, rail, auto. Similar to that, physical layer in our computer also decide what kind of media it is going to use. Is it going to be sent through the copper cable? Is it going to be sent in a format of light? Is it going to be sent in format of electronic current, like plus and minus, 0 and plus? So those will be determined by the physical layer. So now we are going to have a kind of summary of each of the layer here. So here we see application layer. What does it do? It allow access to network resource and it checks which application you are using. Then presentation layer does what? It translate, encrypt and compress the data. What session layer does? So it establish, manage and terminate the session, how long the session has to be. Transport layer does what? It provide a reliable process to process message delivery and error recovery. Then network layer does what? To move packet from a source to destination to provide internetworking. Data link layer is going to do what? It is going to organize the bits into frame and it will provide hope to hope delivery. And what is the physical layer task is, it is going to determine what kind of media you are going to use here. So if I try to go back to my previous slide here, I will be giving a small kind of things here as well. So for example, if I try to summarize everything here, I will be going like this way. First of all, your data will be at 7 layer here. It goes to now presentation layer. It will be changed again, encoded, compressed. Then it goes to session layer, which will be checking that when to start, how big the data is, how long the session has to run. Then it goes to transport layer, and transport layer breaks it into multiple chunks, which we call it as a segment. Then each segment will go to network layer, where this segment will be having one more header here that will be keeping your source and destination IP address. Then this packet moves to the data link layer, so it will remain like that as it is. Plus there will be one more thing extra added, that is source and destination MAC addresses, and then one footer, that is CRC bit. And then finally it will go to the physical layer, where it will be converted to the binary value, maybe 1010 like that. That's how the OSI reference model works. If I try to give you the name of the devices, which device works at which layer, so it is going to be like that. All the upper layer, generally when we talk about, we keep firewall there. So firewall is the device which works at upper layer, and it can be even IDS, IPS, those devices works at upper layer. Then at network layer, the device which works, that is router. So the router is a device which works at network layer or layer 3 device. When we talk about a data link layer, here the devices which works is switch and bridge. These are the two devices which works at data link layer. Sorry for bad writing, because I don't have a digital pen right now here. And then here when we talk about physical layer, we have like NIC of your computer. We have hub. This device works also at the physical layer. And then we have like repeater. So these are the devices works at which layer. If I try to give you the name of the data, what we call it actually at each layer. So all the upper layer here, the data will be known also as a data. We call them data. But at transport layer, we call it as a segment, because it has been broken into multiple part. So each part is known as a segment. And then when this segment is having a header included at network layer with the source and destination IP address, it is known as packet. So what we call it, packet. At network layer, it is known as packet. When it reaches to data link layer, it will be known as a frame. So when it has source and destination MAC address plus CRC bit, all together this packet will be known as a frame. And the format which is available at physical layer, we call it bits, because it is into 0 and 1 format. So these are the name of the data at each every layer, what do we call it. So that was all about in this video. I have tried to explain OSI reference model. I have tried to going through all the 7 layer works, and I hope this video was informative enough for you all, and I would like to thank you for watching.